Hi, this is Jeff Carpenter, and I want to talk to you about a project that I created on GitHub that I call the reservation service. You may want to look at this project if you would like to look at a very simple example of using the DataStax Java driver to talk to Cassandra. The reservation service is based on an example that came from my book, Cassandra, the Definitive Guide, 2nd edition from O'Reilly. In this book, I develop a domain model for a hotel domain that includes the concept of reservations and how they would be stored in Cassandra. Taking content from the book, I've also created a 2-day course for O'Reilly, which you can access at Safari Books Online. This is a quick start guide to application development using Cassandra. For that course, I created this reservation service to provide a source of examples that we go through in the course. The examples in the course involve iteratively making changes to the reservation service application in order to add the Cassandra bits. And this is the service that I'm going to talk through with you. You can download the reservation service from my GitHub account. My goal in creating the reservation service was to have a simple microservice implementation that persists its data using Cassandra and accessing that data through the DataStax Java driver. It's based on the domain model that I developed in the book. For the data modeling portions, you can go and look at the data model as it was developed in the book. The reservation service is based on the hotel domain model defined in the book. The data model that the reservation service uses was actually described in Chapter 5 of the book, which you can download for free at the O'Reilly Ideas website. One of my other goals in developing the reservation service was to demonstrate some best practices for client development. While this is not a full production-ready microservice implementation, it does embody some principles that I think are useful for microservice development. So some of the choices that I made in implementing this application were to use the Java programming language and specifically to make it a Spring Boot application. It's exposing a RESTful API. That way it's simple to test and interact with the service using a tool like curl. So let's start working with the reservation service. First, we'll go to GitHub and get the clone URL for the application. Once we have the URL, then we can execute a clone to get a local copy of the repository. I've just showed you how you might clone the repository using the command line. Another way to load the project is into your favorite IDE. I've chosen to load the reservation service project into my copy of IntelliJ Ultimate. I'm going to give you a quick tour of what the project looks like in this IDE. This is a project that is defined using Maven. So it has a POM file that defines its dependencies. As you can see, there is a placeholder for where we will add the dependency for the Java driver. If you're working through the exercises in the order that they appear in the course, one of your first tasks will be to populate the correct data into the POM. What we can do is to go to the solution that comes at the end. If we check out the exercises complete branch, that will show the exercise in its final form. As you can see, this includes the correct dependencies. Under the source code tree, we can see the main code for the application. There are classes here that define a reservation entity. There's a class that defines a reservation service, which is where the main business logic and database logic of our application exists. There's an auto-generated Spring Boot application that provides the main function for the reservation service. And there's a REST controller. This receives the HTTP requests on our REST interface and invokes the underlying implementation. This class also provides HTTP response codes and interpretation of the payloads that we receive on HTTP requests to the service. In order to effectively work with the reservation service, you shouldn't need to work with the REST controller, but you may find the way that I've implemented things interesting. There's also a test directory that contains a simple test script. These are some curl commands that we might be able to use to quickly interact with the service. The resources directory contains the application properties that you can set to customize the behavior of the application. Here's a quick visual of the architecture that I just showed you in the source code. The reservation service is a Spring Boot application, so Spring handles the starting of the application and wiring all the classes together. For our purposes, we'll run the application in our IDD. This will allow us to debug it. I'll use curl as a simple client to send HTTP requests. Although if you're comfortable with Postman or another tool like that, you're welcome to install and use that tool as well. When the reservation service receives a request, the embedded Tomcat web server receives it at port 8080 and invokes our REST endpoint. The REST endpoint implements operations to create, update, delete, and search for reservations. The REST endpoint calls into our main application class, the reservationservice.java file, whose job it is to interface to Cassandra via the DataStax Java driver. So, when you look at the source code, the things that we need to do to flesh out this simple service using Cassandra is to check the REST endpoint, fill out the to-dos in the main application class, and there will be some work that we'll need to do with the entity. That's the reservation.java. That's the class that represents the reservation data type. Now, you'll notice that I've already written the REST endpoint for you. So our primary work will be in that reservation service class and the entity class. Now that we've had a look at the source code, let's make sure to create the schema that the reservation service will use. We'll use the CQLSH command to load the schema. I used the -f option to tell CQLSH to import commands from the reservation.cql file. I also could use the source command inside the CQL shell. I'll use describe key spaces to show that the reservation key space is present. The reservation service is constructed in its Git repo in terms of branches that describe the starting and ending point for different exercises. I've already shown you how in IntelliJ we can select the branch that represents the exercises complete. This is a branch that represents the final state of the reservation service. So if you would like to see the fully implemented version of the reservation service, that's the branch to use. However, if you would like to work through building up the application a little bit at a time, you may also go in and select the intermediate states, beginning with the very first state, which is called exercise 3B. You could select this, and if you select that branch, then you'll have the initial state for the first exercise. And similarly, if you are to go in and select the exercise 3B solution, you'll see the solution of that first exercise. The name of these branches and the reason that they begin with exercise 3B is based on the overall outline of the Building Applications with Apache Cassandra course. Exercise 3B is the first example that contains a code sample. The branches that you have available to you in the Git repo start with exercise 3B and go through 3B to 3E. Similarly, there are exercises that are numbered in the 4, 5, and 6 range, and these are the branches that you'll see available to you. I've selected the branch exercise 3B, which is the starting point for the first exercise. As we go in here, we can look at the pom.xml file shows where we need to add the dependency for the DataStax Java driver, which you can find online if you search for it in the DataStax documentation. The reservation service is the other class that needs to be modified, and you can see that there are to-dos here that provide the points at which you need to insert code and some clues about what code should be inserted. Once you have entered the code, you'll be ready to run the application. I will skip and pretend that we've already done that by selecting the exercise 3B solution. As you can see, the to-dos have now been implemented, and this is an application that we can now run. Because this is a Spring Boot application, the run configuration has nicely been created for us by IntelliJ, and I can run the reservation service application. The output window will appear at the bottom of the IDE as the application is initializing. Now that we have started the reservation service in our IDE, we're ready to send it some commands. I've prepared a shell script file that contains some example curl commands that we can use. The first command is a post command that we can use to create a new reservation for the hotel NY456 on June 8th. As you can see, the response that's generated contains the address of a URL that we may use to subsequently access that same reservation that was just created. You'll notice that the sample commands that are in the test script file contain one of those randomly generated reservation IDs from a prior run. You'll need to edit these commands to contain the ID numbers of reservations that you create, because the ID numbers will certainly be different. Just as an example, I can retrieve the reservation that I just created using a simple curl get command. So I'll substitute in the ID of the reservation I just created, which is this 6 p.m. UWW. That curl command returns the contents of that reservation. If I return to IntelliJ, I can see the progress of the service in the log and observe the results of the calls that come in. Let's take a closer look at the source code of the reservation service class in IntelliJ. Some of the key code is the code that creates a cluster object and then a session against that cluster that's focused on the reservation key space. We then implement the various methods in the reservation service, starting with create reservation. The implementation for this exercise 3B uses the most simple possible method for invoking statements with the DataStax Java driver. That's the simple statement. As you can see, this is a parameterized statement that we are creating. It's an insert into the reservation by confirmation table using a set of 6 values which are provided afterwards, and then the statement is executed. The implementations of the other operations on the reservation service are similar throughout the rest of this class. They use simple statements. If I look at one of the other exercises, such as exercise 3C, that solution begins to use more advanced methods for creating and executing statements. So, for example, exercise 3C, we see the usage of prepared statements. Exercise 3D is yet another equivalent way of creating and executing statements. It uses the query builder, which is a Fluent API that is provided by the DataStax Java driver. And the final example that we see with the exercise 3E solution is the very last way that we have of creating and executing statements. And this actually makes use of the object mapper, which is provided by the DataStax Java driver. You'll find that there's actually a separate POM dependency that's required, or an additional POM dependency that's required to add in the mapper, and that for this particular exercise, that changes are required to the reservation class in order that we may provide annotations that the object mapper can use. That's a quick guided tour of the several different ways that the DataStax Java driver provides to you to execute statements. This is a fast way that you can jump back and forth and compare what these different ways of executing statements look like on your application and decide which might be best for your situation. I will leave you with a few caveats about the reservation service. It's not a production-ready service. It does minimal validation of the data that you pass to it, and it does not have very advanced fault handling either. However, it is a complete working end-to-end example. There are some things about the data model that are a little bit inconsistent or unsophisticated. In some place, strings are used as unique identifiers, and in other places, like the guest ID, a UUID is used. You might want to consider having a data model that is a little more consistent and well thought out for a real-world application. One final caveat is that all of the code for the reservation service is provided in a single Java package. This is just to keep things simple. This simple focus of the reservation service allows it to focus on just adding the Cassandra bits to the application. I leave it to you to add in the more sophisticated aspects of making a production-ready microservice. If you're looking for a true reference application that demonstrates the features of Cassandra and DataStax Enterprise, I encourage you to check out Killer Video. This is a video sharing application that you can access at killervideo.github.io and killervideo.com to see an actual running instance. Thanks for joining me for this quick overview of the reservation service. I hope that it gives you a real jump start in learning how to create microservices that work with Apache Cassandra.